This lesson is on polynomial long division, and it is sort of as bad as it sounds. So first of all, it's important to understand the basics of just regular old long division. So notice here, I've given us a regular division problem, which normally we would probably plug into our calculators. But let's talk about how this works when back in the old school days we had to use long division. When we use long division, we looked at the value on the outside, which is what we're dividing by. Dividing by 5, it goes on the outside. We're going to take 5 into that first term. Doesn't work in this case, so we're going to look at 25. So 5 goes into 25, and it goes in 5 times. So I'm putting how many times it goes into it on the top, then I'm multiplying 5 times 5 to get 25, and I'm subtracting it. So keep all of these steps in mind because this is what's going to continue to happen. I'm now going to subtract 25 minus 25, which gives me 0, and I'm going to bring down the next term, and then the whole process repeats. I say, how many times does 5 go into 7? 1 time. 1 times 5 is 5, so I'm subtracting it. I'm subtracting to get 2, I'm bringing down the next value. 5 goes into 28, 5 times. 5 times 5 is 25. I'm subtracting to get 3. Bring down the last value. 5 goes into 34 6 times. 5 times 6 is 30. I subtract to get 4. Now, when you first learned how to do it, before you talked about decimals, we would just say remainder of 4, which would of course mean 4 that would still have to be divided by 5. This is a reminder of old school long division, because now we're going to do this with polynomials. I know. Just take it step by step, and this is not as bad as it probably seems. The most important thing I can tell you about dividing either long division or synthetic, which is what I will show you next, is make sure that when you're writing your first polynomial, that you have every degree from the highest degree all the way down to 0. So if I didn't have an x squared value, I'd have to put in a 0x squared as a placeholder. That's the most common mistake that people make. Now let's see how we do this. My first value goes inside, 2x cubed minus 11x squared plus 13x plus 15. Notice I had a 3, a 2, a 1, and a 0. On the outside, I put whatever I'm dividing by. Now what I'm going to focus on is my first terms. I'm going to look at 2x and 2x cubed. I'm essentially dividing those terms. I'm saying 2x times what gives me 2x cubed. If I'm not sure, I would take 2x cubed divided by 2x, and that would give me x to the second. Feel free to do this work off to the side. Which means I'm going to put x to the second, and notice I'm putting it above the other x squared. So I'm stacking like terms. Then I'm going to take x squared times this whole thing. So x squared times 2x is 2x cubed. Notice that makes these two exactly the same. X squared times minus 5 is minus 5x squared. Now here's the second most common place to make a mistake. I'm subtracting all of this. Notice I put it in parentheses while I was talking to you. I'm subtracting everything, which means I'm going to keep, flip, change, change. Because now I have 2x cubed plus negative 2x cubed, and those cancel. And that's what I want to have happen every single time on the first terms. The second terms is just whatever I have left. So negative 11x squared plus 5x squared gives me negative 6x squared. Just like in the long division before, I now bring down the next term. And the process starts over. So I'm looking at 2x and negative 6x squared. Again, I'm saying 2x times what would be negative 6x squared, or I'm thinking about negative 6x squared divided by 2x. If I divide, that gives me negative 3x to the first. So that means here, I'm going to put negative 3x. Here I'm going to put what negative 3x is when I multiply it by both terms. So negative 3x times 2x is negative 6x squared. Notice again they match. Negative 3x times negative 5 is positive 15x. Again, don't worry about the signs quite yet because I'm subtracting all of this, which means I'm going to keep, flip, change, change, since I'm subtracting both terms, which means these two terms will cancel, which is what I wanted to have happen. And 13 plus negative 15x gives me negative 2x. Bring down my last term. Same thing I did before. I'm looking at 2x and I'm looking at negative 2x. So if I took negative 2x divided by 2x, what would I get? I would get negative 1. So that's the number I'm going to use, negative 1. Negative 1 times 2x is negative 2x. Negative 1 times negative 5 is positive 5. Again, I'm subtracting that whole thing, so I'm going to keep, flip, change, change. 2x and negative 2x cancel. 15 and negative 5 is 10. No more terms to bring down. So now I have a remainder. My remainder is 10, but it's still being divided by this. And so instead of writing r for remainder, I'm going to write plus, because I'm adding 10 divided by 2x minus 5. 10 divided by 2x minus 5. So this is my solution. What we want to have happen eventually, or where we're going with this, because I know it's important to understand why are we learning how to do this. Eventually, we're going to have to do some long division so that we can solve polynomials that have a greater degree than just 3 or 4, which is all we've done so far. So this, having a remainder, is not ideal, which means 2x minus 5, not a factor of my original function. So I hope to not have anything with a remainder. Let's try another one. Again, I warned us at the beginning, when we use long division, on the inside, we have to make sure that I go from 5 every step all the way down to 0. So x to the 5th minus 3x to the 4th. Notice there's no x to the 3rd, so I'm putting a placeholder. There's also no x to the 2nd, so I'm putting a placeholder. The rest of them I'm going to write just as they are. Notice also that this is in standard form from highest to lowest. On the outside, x minus 3. Now it's going to be kind of a long process. So again, I'm focused on those first terms. So x and x to the 5th. I would say x times x to the 4th would give me x to the 5th. So x to the 4th times x is x to the 5th. Again, if you need to do that division off to the side, feel free to do that to find this term. X to the 4th times x is x to the 5th. X to the 4th times minus 3 is minus 3x to the 4th. I'm going to subtract the whole thing, always put it in parentheses, which means I'm going to add the opposites. That cancels out my first term. And look what happens here. I actually get negative 3x to the 4th and positive 3x to the 4th, so those cancel. And that gives me 0x to the 4th. It also gives me 0x to the 3rd and 0x to the 2nd. And so if I had a term here, I would go ahead and bring down that 0 just as a placeholder. But now I'm going to go all the way out here, and I'm going to look at bringing down all of these, which doesn't matter, bringing down my 12x minus 33. I'm going to bring down both terms, which normally I wouldn't do, only because I ended up with all of these zeros, which meant I would sort of get to start over. So now I'm going to look at x, and I'm going to look at 12x. I'm going to say x times what? What would I multiply by x to get 12x, which is of course 12. So that's a 12 up here. Notice I'm stacking it above the other constant. So 12 times x is 12x. 12 times minus 3 is minus 36. I'm subtracting the whole thing, which means I'm going to add the opposites, which gives me 3. That's a remainder of 3. So it's plus 3 over x minus 3. So my solution is x to the 4th plus 12 plus 3 over x minus 3. That's my answer when I divide. Here's one for you to try on your own. So press pause, try this question, then press play to check your work. Again, on the inside, I have to start at the highest degree, which is 3, so 2x cubed. I do have an x squared value, I do have an x to the first value, and I do have an x to the 0 value. On the outside, this one's a little bit trickier. I have x squared minus 3x plus 4. Shouldn't matter, same idea. Let's take a look. I'm looking at x squared and 2x cubed. Again, if you need to do the work off to the side, if I divided that, I would get 2x. That's the value I'm going to use. I'm going to stack it on top of the other x value. 2x times x squared is 2x cubed. 2x times minus 3x is minus 6x squared. 2x times 4 is 8x. I'm subtracting all of that, which means I'm going to add the opposites. That makes my first term go away. My second term is now 8x squared. My third term is negative 24x. And my last term is plus 32. Now I'm going to repeat the process, looking at 8x squared. Again, if you need to write 8x squared divided by x squared off to the side, feel free to do that. So that means it's going to be a positive 8. So 8 times x squared is 8x squared. 8 times minus 3x is minus 24x. 8 times 4 is 32. And this will be our first example where when I add the opposites, I end up with a remainder of 0. So that's kind of exciting because what that tells us is that 2x plus 8 is a factor of this polynomial, as is x squared minus 3x plus 4. Those are factors of this polynomial. So just as a fun little exercise, if I were to try to solve this without using long division, this is one of those where I would factor by grouping, which would give me 2x squared and then x plus 1. And over here I would get minus 16, and then that would give me x plus 2. Yep, that one wouldn't factor in that way. But that's okay, because we could actually end up factoring this, and obviously it would factor into 2x plus 8 and x squared minus 3x plus 4, which is great.